Well, I think I've left this sitting here long enough. 323 hasn't budged. It hasn't budged. It's been over a week now. So, safe to say, refrigerant loop is done. No leaks. So, be able to take that off, get out of the way, leave the nitrogen in for now. And you need to finish the water connections. Yeah. So I'm finally working at setting up the IMP board for the outdoor fan motor. Whenever I've used this externally just to drive a motor, I've always like hooked up a rectifier and then put, landed positive on the right one and negative on the other one. And here's like I was making this rectifier externally. I had it all heat shrunk and everything just now. And as I was looking at this, handling it to actually mount it on a little insulator board, I was drilling the holes to mount the board. I'm like, see the two IMP modules. They're just two of them, one for each motor. And I'm like, why the hell does that look like a rectifier bolted in there? So I can't read what it is because it says IMP1, IMP2, and then this is blocking it. But I'm like, dude, that's a rectifier, I'm pretty sure. And I'm looking through here. I go, yeah, this is the classic filter network. You got your little filter caps going across for the transients or whatever. Then you got your little, goes through the chokes, one for each line, over to another one on the output. And then you have your MOV, your metal oxide varistor / surge suppressor across the AC, to shunt, high voltage spikes. And then here's the AC to AC input. And, you look out right here. It's the same thing. AC in the middle and then minus and plus. So I'm like, no way. So I'm in here now checking it out. I'm like, well, if this is the case, this is going to go all the way through the filters and go right here. And it does. And this other one, go through all these filters and then hit this one. And it does. So if you change this over to diode check, so we could check the forward biasing, put the voltage across from each one to here, open, which it should be. And then, there we go. 5.5 volts to bias that. It should be likewise on the other AC input. And then if we reverse the polarity, should get the same thing on this side. There, open over there. This is how you want to check out your rectifiers on your IPMs anyway. A lot of people don't really check these anymore. But you could check outputs, likewise also, since I'm in here. So here's like a layout for like a VFD or a IPM modules. This module has the rectifier built in. Same general layout of all the MOSFETs or IGBTs, on those type of units. And you could check your outputs, your UV and your W going out to the motor, to the DC bus, to kind of see if any of the drivers are obviously shorted or blown. So we just got done checking a single phase, going through 4 diodes to check the external rectifier. So you could do the same thing. You put it in, for rectifiers. So you stick your probe, you do your UVW outputs. So one side you should read like a diode, which you're actually just going to read those diodes right there, actually. Just that they're made for like protection. But usually you can tell if your module is probably good. So it's open there. So go to the negative side. So you got almost 5 volt drop. The E and the W. Same thing. And then you're going to switch the polarity. So we'll go to the red down here in the U. And then we're going to do the positive. And of course, it's open the other way. This is a good module, so I know it's not blown. Same thing. Over to this one. Same thing. So you could take like VRF, ductless modules, all that stuff. If you really look at them, you could kind of trace them out, figure out where the DC bus is. All you do is really look for the minus side of the capacitors. Plus, you can kind of figure out which one's which. Trace them out. They always feed, in there. Some modules, like I said, will feed the 3 separately, which probably this right here, 3 resistors. And there's 3 over here with a little surge suppressor. So, yeah. So a lot of them will have 3 separate these, because depending what kind of control they want to do, and they're using current limiting resistors, or probably like 1 ohm or something, or a fraction of an ohm. and the microprocessor could be looking for a voltage drop across them or something. Yeah, so that's how that works. Take 20. Yeah. 2 perfect holes. This does make some nice clean holes when you want them. Instead of using a hole saw cutter or a plasma cutter, it burns everything. So what I did was I kind of lined these up. They'll straighten out once I get the other holes punched through. But this is the side cover of the ductless case that I'm using for my next version of my water heater heat pump. So today I did some plumbing work, basically. Get the coaxial heat exchanger 3/4 inch fittings up here. So that's going to be awesome. So I had the refrigerant side pressure test for over a week since I did anything to it, and it held perfect with all this freaking shenanigans of repiping this and a little clusterfuck there on that bell end, but I fixed that. We'll be okay. Don't you mind that? So today I kind of went over here and just kind of used scrap pipe, of course. Everything's recycled. These used to be connected directly to this, but I kind of just cut them and repurposed them. So I brought this one up here. We need to remember to mark each one. So if this is liquid, this will be the coolest, so it'll be the entering. And then this is the hot gas side going in. So for crossflow, this will be the hottest water leaving. So this will be the entering water, this will be the leaving water. Recirc pump to my water heater storage tank. Since this is actually the water heater when the elements are disabled. Again, this is the built-in evaporator coil to absorb heat. But I teed it off, like I said in the other video clip, just in case I want to hook the high wall back up inside in the summer or whatever, just to use that one. Might as well cool off that little room whenever it's heating the water, which is what it's been doing now, what it is doing now. I just finished heating up off the solar power, and it was getting this room down into the 50s. So the garage open and me doing work out there has gotten up to 64 degrees, you know, and it's plenty warm out here. It's like 70 plus over 70 probably right here. So because what is this, January 31st, or is this the 1st of February today? Oh, it's February 1st. So yeah, February 1st. It's basically a 70-degree day for us here in the Phoenix area. So I went ahead and also slapped some relays in here. This one, and these will be 24-volt control. Just have a transformer from the thermostat inside. Just send 24 volts out to these two at the same time. This one here is going to close the 2 poles to the 240-volt compressor. And then this one here, I could have used one contact for the compressor, one for the fan, but since it's a low voltage control, I don't want them anywhere near each other, so this one's just going to switch on the fan. So right now I'm vacuuming down. I had it under pressure for well over a week, and it held over 300 test pressure. So now I'm vacuuming it. I vacuumed it down once, and I got nitro in it, and I'm vacuuming it down again right now. And so it's pulling down. So I want to hopefully get it all pumped down today, and then break that vacuum with a little bit of R410 in there. And then that way it'll be ready for me to mess with. Okay, I let that vacuum pump run. Actually forgot it and let it run all night. So came out here this morning and broke the vacuum with some R14. So it's under refrigerant pressure now. And so I'm going to work on putting the side cover on and go from there. I had to fight this a little bit to be able to get something hooked up for a pressure test. Almost thought of just hooking water up to it. But, you know, if you got water leak, you got to get the water out before you can braze it. So I was able to find all these pieces in my junk drawer. Got this hooked up. The only 3/4 plug I had was plastic, and it kept leaking. So I really gooped it up with Teflon now and kept the pressure at about 29 psi, and it's been holding for like 30 minutes, so I think we're good. When I first put some in there, I did have one leak, and I missed the spot right here. So at least it was right here I could get to it. Wasn't none of those lines all the way back there. It was that one, the first one I made out of all the water connections. So it should be good. Water pressure is pretty high at my house. I think it's pushing like 80 psi or something. So yeah, definitely need to be good. But yeah, so this is how this turned out. This is just an old sticker I pulled off and all the metal shavings stuck to it. Okay, got some temporary electrical connections made. Reused the fuse block from the unit I took it out of. Got this relay here. It's going to stop the compressor. This one, like I said, is going to probably do low voltage, start and stop, just to send the signal in for speed, which I'm going to adjust right here. So right now I just have it directly connected and power is just being supplied to there. Anyway, so the fan, I got it running nice and low. I can just kind of fine tune it right here. This will be the evaporator coil where this thing runs. So go ahead and stop that. And I think I'm going to do is kind of disconnect my refrigerant lines and get this front cover on. That way it's kind of ready to run. Okay, got the front cover on. The fan's just kind of cruising. Don't have the compressor started. I found a bunch of fittings and a pump. Actually, this was in a bucket that was all brittle and falling apart out back. So it actually still had the setup from last time. I actually had those, the tubes, some fittings. So I have it hooked up. Turn the pump on. Always love mixing water with electricity, right? It's priming. There she goes. And we got it choked quite a bit at first. And then what I'm going to do is probably hook up a 24-volt transformer just to start the compressor and kind of get the charge close. Okay, the time has come to do a full test. I had to leave for a little bit, just got back. So water actually feels like it's still like 80-ish. So that's okay. About 3.5 gallons in there. I'm going to have to add some more. I have both the field piece and the testos hooked up. So I put the field piece on the refrigerant side. We got the suction discharge over there. And then we got the suction temperature, liquid line temperature right here. And then I've got a testo probe on the entering water, this testo probe on the leaving water. Then I have a testo probe on the entering air and then the leaving air, whatever, right there. So I'm going to put this cover back on and we'll start it up. I actually charged it up a little bit ago, pretty close, without taking any readings. So now I'm going to just get the panel in place and give it a little test run. Okay, front panel in place. We've still got the fan wired direct, so as soon as I put power, it should start where the potentiometer is left. That pop was normal, so the capacitors are drained complete out. So fan motor should start. Looking over here, field piece pressures are equalized, about 80 degrees. It is warm today. So, there's the when it runs, we'll look at that. Over here, got your temperatures. You can see in the garage, it's probably about 71.6. Neutral air blowing through. And then about 74, 72 on those lines. The water, when I put my hand in there, is probably definitely over 80, or about 80. Because it just, I don't know, feels about like that. So I ran it a little bit earlier to get the refrigerant in there and I was circulating water. So this is a, anyone asks, this is a Samsung Tab. Is it Tab 8? I don't know. It's one of the newer ones, and it's like 11-inch or something like that. Split screen, 2 apps. It's got enough power that it's doing it. I remember the cheap tablets I would use way back when I first got Testo smart probes. The cheap ones could only connect so many Testos at once. But you can see here, I'm running a field piece and a Testo app, and I got like 4 tools connected at the same time on each one. So there's 8 tools connected. Yeah. So this will be my air. We'll figure out which one's which. 58, 746. Okay, so this one will be leaving air, entering air, and then these will be the water temperatures. We'll figure out which one's which when it starts running. Yeah, so I'll flip the switch. It's going to put power to the pump, power to this at the same time. Oh, looks like this kink came back. I tried to, let me fix that real quick. Well, I couldn't quite fix it, but I think it's going to flow anyway. So turn it on. Compressor's going to start because of the contactor off of this 24 volts, and then the pump. And the loudest thing over there, of course, is that submersible pump. Compressor's running. Fan already was running. So there's some pressures. You can see this temperature drop. Earlier I had almost a 20-degree split when I was adding some refrigerant. And there's my water temperature. So that's leaving, that's entering water. And my entering and leaving air. And then my pressure's over here. Kind of, it's not going to be exact on the pressure. I'll have to, I figure it's close enough until I actually do mount the unit. I just want to make sure this thing works good before I do that. And let's make sure it's flowing enough. Water sits, that's flowing. And usually, what I do with my control is I cycle the pump. So my existing heat pump I have built, it kicks on the pump at over 100 degrees liquid line temperature, and then it goes to high on 110. And it always gets me pretty hot water leaving. So right now, got a 20-degree split approaching on the air already, and you see 83-degree water with a 104-degree leaving. But what I like to do is I like to have it staged, and I'll have to recalibrate this one since it's a different unit, but I like to do it so it only discharges really hot water. So it's creeping up there. Obviously, when you use a heat pump to heat water, you kind of run it a little high when the tank water temperature gets high. You know, you're pushing the compressor a little bit, but I mean, it's just nature of it, you know. This is R410, so obviously that's, you know, a hot day. We're just approaching the pressure you get on a hot day in Phoenix. So it's got a ways to go. I don't sweat it if it hits 500, but once you, for the peak, this would be like where it run when the water was cooler. Yeah. So almost could have just a little bit of refrigerant added. See, it's got a little bit of superheat there. Suction pressure is just a little low. Only got a couple degrees of subcooling. And once again, you know, I just throw it together. Kind of come out with the coil, just running off the top of my head. Capillary tubes. This time I used the capillary tubes that were in the unit the compressor came out of, so I didn't need to calculate this one. And it works. I know if I add a little bit of refrigerant, it'll bring down that superheat. That suction temperature felt pretty good earlier when I just put my hand on it. Obviously, it's like 72 right now. That's in a good spot. Yeah, it's not as cool as it was earlier, so might take a little bit. But you can see the air temperature is going from 72 to 52, where the fan speed just happens to be, which is pretty good. Want to keep it just enough to move enough air and then be efficient. Tell the compressor's, you know, fully loaded, and we could calculate that compression ratio. It's can already tell it's more than 3-to-1 because 150 to 450 would be 3-to-1, so it's running probably pushing 4-to-1 right there, 4-to-1. So it's pushing it a little bit. If I had a little more refrigerant, I'd probably get this up at this temperature, more to like 130ish or something, or even more. So I don't have anything hooked up to add refrigerant to it right now. So obviously that's going up, and if I had my automatic control, it'd be increasing the water pump speed. But what I'm going to do right now, see, we've got 93 to 123, so that's pretty freaking hot water coming out. So I'll just barely crack this open a little more. That sounded like it made a big difference. It would have had some air in there. It's going to drop this like a rock. So let me actually crack that back down just a little bit because I want to see how well it actually heats water. And you want to limit the gallons per minute on a heat pump that's heating water to make it heat the water. So that water temperature here is already up to 95, so it's already went up like 15 plus degrees in a few minutes that we've been running this. It's only 4 gallons in there though. So we're going to get it up to 130 pretty quick. That's going up. So we'll just increase this just a pinch. I mean, the slightest pinch. Look, it's slowly dropping right there. You're running like 130-ish. that water in that bucket, uninsulated bucket, mind you, is just heating right up. Back to the air temperatures, 73, 53. So it's cooling the air right here from that evaporator. Pretty cool. Once I get this all together, I'll have to like clean it up a little bit. It'll look like something. I just moved the probe. This testo was on this elbow up here, so it wasn't even touching all the way. So it got it on there, and you could see the inching water's just shooting up. So that bucket was way hotter than I realized it was. So it was up to full temp already, and then that pressure started shooting up. So that explains that. It's still climbing, so it's probably almost up to full, up to 130 in the bucket when I turned it off. So it heated up that water pretty quick. Of course, that's a 50-gallon water heater, and it does take an hour to an hour and a half to reheat, depending on how much water was used. With my little tiny compressor, this one's like a couple thousand BTUs larger. Not a whole lot larger, but it's bigger, and it's 240 volt. Those are pretty up there. Anyway, with that, we'll end it. Or this is going forever. Don't forget to like, share, subscribe, and comment. Catch you guys later.